Okay, hello everyone, and welcome to day 2. Guys, today we're going to look at quadratic functions in vertex form. Okay, it's kind of an easy form to find the vertex in, obviously. Okay? Again, today's objective, graph a quadratic function from vertex form. Alright, we know standard form. ax squared plus bx plus c. That's standard form of a quadratic. Vertex form looks like this right here. Okay? Today we're going to introduce the h and the k. And you might remember them from absolute value. Today's essential question: how do we express a quadratic that does not go through the origin? I mean, so far we've only had a. We haven't used h and k yet. It's the h and k that moves it away from the origin. Okay? Again, remember the quadratic parent function. It's y equals x squared. All right? It looks like this. That's the graph. And then we've added the a to it. And the a makes it wider or narrower or flips it upside down, but it keeps it at the origin. It's still going through the origin. Now we want to move it around. And that's what the h and the k does. It changes the vertex. All right? And again, remember we looked at the absolute value function. The parent function looked like this: y equals the absolute value of x. And we use this h and k to move it from the origin. Remember, minus h plus k? The h moved it right and left. The k moved it up and down. And the h was always the opposite because it says x minus h. So whatever was inside here, we use the opposite to find the vertex. All right? We're going to do the same exact thing with the quadratic. All right? X minus h squared. That makes it a quadratic, okay? Let's look at Desmos. Guys, this is just a screenshot from Desmos. But I'm going to go over there and we're going to set it up. All right, this is Desmos, and I'm going to start from nothing here, okay? If I just say y equals, and let's put our a in there. All right, make a bracket and say x minus h. And put a bracket. And now we're going to put squared. And then we're going to add k plus k. And it's saying right here, add a slider. See, it'll automatically prompt you. Do you want to add a slider? Say, you bet I do. All. There. Our quadratic appears as if each one of these is 1. So a is 1, h is 1, k is 1. And you notice because h is 1, a positive 1, h, it moves it to the right. All right, but if I put it in here, this would say x minus 1. So remember, when it says minus 1, you move it to the right. You guys can do this in Desmos and make yourself one of these. You can move the a around. All right, you can move the h around. That moves it left and right. All right, again, when h is negative, like let's say it's negative 4. If I put that in here, so it's x minus negative 4, a minus, we're subtracting a negative, that's the same as adding a positive. It would say x plus 4. Right here, it would say x plus 4. So when it says x plus 4, you move it to the left 4. And then k moves it up and down. Again, positive k moves it up. Negative k brings it below the axis. When k is 0, it sits right there. Okay? Same with h. H might be 0 too. So it just moves up and down then, right on the axis. Okay? All right, again, as an example, just if we're going to find the vertex, if they give you the function, it looks like this. That's vertex form. All right, a is 1. Guys, here h is 2. H is 2, not negative 2. H is 2. It's the opposite from what you see right there. H is 2. And K is positive 5. Okay, K is 5. If I put this in Desmos, this is what I got. I can see what it looks like. And we know that the vertex here is at 2, 5. Or, I'm sorry, yeah, 2, 5. I can see it right there. All right? And that's the most common mistake. When it reads x minus 2, that means the graph is moved 2 units to the right. The plus 5 means 5 units up. Okay? Next example, x plus 2, and then x minus 5. So the minus 5 took it down 5. But remember, that plus 2 means the vertex is at negative 2. All right, so we moved back to the left 2. And then down 5. When that says plus 2, you move to the left. Okay, next example. This one just says x squared minus 3. Guys, that means h is 0. So it just slides up and down when h is 0. Okay, minus 3, it moves down 3. So the vertex is 0, negative 3. All right, the axis of symmetry is always x equals h. Always. That's one of the reasons we put it in vertex form. It is easy to find the axis of symmetry. All right, example 4. Guys, in this case, k is 0. It doesn't go up and down at all. We're just going to slide it left and right. All right, along the x-axis. This says minus 1. That means we move it to the right 1. All right, that's what that means right there. Okay. As the last thing, I just want to revisit this rate of change idea. All right, there is one little problem in the summary about this. It's the first problem. Again, remember the value of a, it changed the shape of the graph. Because what it's doing, it's affecting the rate of change, right? Which is kind of like the slope, if you remember. Even though the rate of change is changing, between any 2 points, we can calculate a slope. All right, over any interval, the rate of change of 2x squared is twice the rate of change of x squared, of course, over the same interval. Because that's the ratio of their a values, 2 over 1. You can calculate this blue line right here, the slope is twice as steep as the red line here. Okay, that's the same interval between 0 and 1. All right, you all. Today's 2 vocabulary questions are right here. This is one of the answers to the notes assessment. Again, the first question, how does the value of a, h, and k alter the graph of the quadratic parent function? It's a matching, where you match up what they do. And number 2, you're just going to select which of the quadratics is in vertex form. All right, that's what the vocabulary question today is. No real vocabulary words, but I want you to understand a, h, and k and what vertex form is. All right, that's it, guys. Go ahead and fill out today's notes assignment and complete the summary in the green folder. And then get ready for the next Zoom meeting, all right? Thanks a bunch. My time's up.